Hello again, everyone. This is Steve. Got a new puzzle for you. This one, this one is pumping out a 200-foot mine shaft. Now, most of you are probably like, "Well, I have no practical use for that." Well, okay, maybe aren't pumping out a 200-foot mine shaft, but maybe you have a hole that you have to pump out. This would still work in the same way. Even if it's not a mine shaft, if it's a vertical hole and you need a simple mechanical way to pump it out, this would work for you. Rules for this puzzle are obviously all water pumping must be done mechanically, just like all the others. The mine shaft must be evacuated of no less than 98% of the total water stored in it. There is no time limit, so that's a nice little thing that you don't have to deal with. You don't have to, like, you're not up against the clock trying to get this thing pumped out. It's just however long it takes, whatever the wind is, and so on and so forth. Number 4, water does not regenerate. In other words, once you pump it out, the ground doesn't automatically refill it. So that's a nice benefit too, because you're not fighting against nature trying to keep that thing pumped out. Number 5, water must not return to the well once removed. So in other words, once you pump it out, it should not be allowed to come back in. So it has to be completely evacuated out of the area. This is my model of what that might look like. Now, the original puzzle, there was no information on landscape, location, anything like that. It was just a 200-foot vertical hole that happens to be a mine, and you need to pump it out. This was how I pictured like the situation might be. This could be a completely flat valley. This could be, up on a hill like this. It could be any number of things. Like I say, for my purposes, I made it up on a hill. This is kind of more zoomed out for what I kind of pictured the scenario would be. Now, as you remember from the original video I did about the windmill pump and pumping up the to the water tower using ram pumps, the windmill pump, and all of that, that is a very, very good way to pump water mechanically. You throw it out there, turn it on, let the wind do the thing, and it does the needfuls for however long it needs to. You turn it on, walk away, and it does everything for you. In this case, like I say, since there's no landscape information given, it's obviously going to be a hole. You're not like coming down a hill and going back up a hill like it was with the Desert Spring one, or a number of other things like that. This is basically a 200-foot hole that you have to evacuate of water. So ram pump isn't going to work in this situation, which is a total bummer for me. I love ram pumps. But again, with the ram pump, we're pumping water up to a location where we want to store it. In this case, we're trying to remove it. So ram pump's not viable in here, but the windmill is. So that's what we're going to use for the power source for this pumping experiment. Anyone who has ever worked with a windmill, and you may not have, you would know that a windmill, the typical classic windmill, has a gearbox on the top that's connected to the fan blades. The typical gearbox, though, is basically just a drive shaft to a gear that has a little plug or rod, whatever you want to call it. It's a little knob that sticks out, and it connects to a vertical drive shaft. Not a rotating drive shaft. This is literally like a rod that goes down from the top of the windmill down to this. Like what they used them for is they'd connect them to pitcher pumps, and the pitcher pumps or any number of other vertical up and down style pumps were connected to that. So as the windmill turned, the rod went up and down, and water pumped, and everything was all hunky dory. In our example, that's not going to work, primarily for the depth of the well. Anyways, this right here is the other type of gearbox that your windmill can have. This is a 90-degree gearbox. This takes horizontal movement or motion and turns it into vertical movement. You connect that to a metal drive shaft all the way to the bottom, or you have a second one that converts it from vertical to horizontal. And you'll see in a second here why I'm doing this instead of the up and down vertical one. This right here is one of two possible ways that we can pump this out and do it mechanically and do it in a way that the windmill can actually support. Windmills have up to 75 horsepower on them. Now that sounds like a lot, but once you consider the fact, and this is one of the gotchas of the puzzle, is the fact that at the top, a couple psi of pressure or water, a couple pounds of water that you're having to lift up and evacuate from the mine. As you get towards the bottom, and as you keep going down, that pressure keeps going up. Because as you remember from before, water has a weight of 0.4 pounds per foot of fall. So at 200 feet, you're hitting about 80 psi, or 80 pounds of water weight that you have to lift all the way from the bottom to the top. So all of a sudden, that 75 horsepower is sounding real good. And of course, 75 horsepower is only if that thing's like, the winds are blowing 15, 20 mile an hour, and that windmill's just, doing its thing. So, it can go anywhere from 1 horsepower up to 15. So the assumption here is that it's going to be able to do the job. It's not so much, can it do the job, does it have the horsepower, because it has the potential. So you have to assume that, the windmill can do that. But again, you have to think about this because, as it gets further down, it gets harder and harder to pump that water because there's more volume that it has to lift and more weight of water weight that it has to lift. And this is where this comes in handy. The way this works is these are like little rubber plugs connected to a rope or a chain. And what they do is they go down in the water. They don't really grab anything themselves, but they come up to this drive pipe and they seal against the sides and they capture this little pocket of water. And they just kind of go up, 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 up until they get to the top here where the pipe ends in this little collector of sorts, this accumulator, if you will, or whatever you want to call it. That water then flows over, goes over to another device or wherever you want it to go. The plugs then come up here, go back down, come back up, and they do their thing. A slightly different version of this, which doesn't require the drive pipe, but requires a slightly different setup, has little metal cups on it, which they go down in the water, pick them up, and they come over the top, and dump the water off. And I'll explain that one in a second, but this is the first one we're going to work with. These are seen quite often in third world countries. You stick a guy on a bike, he pedals like crazy, the spindle does its thing, the chain goes down into the well, comes back up, drops the water off, goes down, comes back up, drops the water off, just like this was showing. It's very simple, very efficient pump. Doesn't take a lot of horsepower to run it because your column of water, even though it's at like 80 psi, your actual total pounds of water is not that great. So, and this right here I'd say is roughly about a 2-inch drive pipe. So all of you mathy kind of people can probably figure out what the total weight is you're going to have to lift up to the top. But long story short, at the beginning you're going to be pumping water like crazy. Towards the end, it's that pump's going to be struggling a little bit, and the water pumping is going to slow way down, but it will continue as long as you got sufficient wind. But anyways, going back to my windmill, you've obviously got your vertical shaft, and this isn't like a rod or some piece of metal. Well, it'd probably be metal pipe, but this isn't like a drive rod like you'd have on a normal windmill. This is like a drive shaft you'd have on, I don't know, any other normal rotary motion machinery or whatever. Of course, you got the 90 degree up here, and you got the 90 degree box down here, which then goes to the horizontal, which then goes to your wheel. Wheel turns, it goes down, comes up to the bottom of the drive pipe, grabs that water, comes up here, water evacuates out, down the hill it goes. And like I say, at the beginning it goes real easy, but then as you get further down and further down and further down, the pumping slows down, but it still continues. And one of the things you have to consider with this is the drive pipe and the chain, which there'll be a duplicate one of these down below, that has to be anchored to the bottom. One of my solutions was simply to take a large piece of steel, like I don't think you have to worry too much about things floating up. Your drive pipe might float a little, So you might have a little buoyancy with that, but you're not going to have a lot. The biggest thing you're going to have is the vertical friction. So you're going to have to anchor that so that doesn't move up, and probably anchor it to the bottom piece. The bottom piece, though, which has the identical wheel, is mostly you're going to have to deal with the actual, the friction and the motion of the chain and any pulling that it does on the entire assembly. If this is anchored to something not connected to that base piece, then you remove that as a possible obstacle that would take that bottom plate and lift it up unintentionally just due to friction and other things. But really, though, the friction is primarily going to be against this right here. And if you don't have this anchored somewhere else, it will pull that bottom plate up and it'll jam up your system and just all kinds of other things. So your bottom plate holds the chain or the wheel and takes the chain and everything, anchors it to the bottom. That way you can get down, because at 200 feet, to take out 98%, you have to get it down 196 feet. So you've got 4 feet of play. If you could do it right, you can probably only have like a foot of water in the bottom when you're done. But again, you have to anchor the drive pipe and make sure that can't run around and stuff. But yeah, once it's pulling water up, it spits it out, goes down the hill, and walk away, leave it for a few days, and it'll pump the whole well, or pump out that whole mine. So, and of course, if you're trying to do this on a well, you end up pumping out pumping well water out for as long as you want to. But in this case, we're not doing that, but it can be used for that too. Now, the other one I mentioned, the chain cup pump, which is similar to this one. That one operates a little differently. You don't have the drive pipe. Instead, what you have is this comes out to the wheel. You have this thing. It's still doing its thing. No drive pipe. So how does that get the water out of there? Well, what this does is the water will come up, and it'll come. Your pump chain will come through a little hole in this water trough. And what that hole does is, well, the hole obviously what it does is it lets that through there. But what you need to do is, because you're going to have your trough, you're going to have the sides on the trough, but then where that chain comes up, you're going to have that hole lined with walls similar to what the trough has. The reasoning behind that is, when you pour this out, you don't want it going back into the well. So what this does is this will come up here, and it will pour out on this side, and of course you got those two there with the risers around the holes to keep the water from going back down into the well. But yeah, this will come up here. The buckets will pour the water out. It'll go on the trough. It'll drain down, and off you go. Now, if you find that you're having too much of it returning to the well, spilling over as it comes over, comes over here and goes down the second hole, one thing you can do is take this, extend it out to another pulley like up here, so that they come up, they hit the second pulley, dump out over here. They're well away from the two holes with the risers. Bring that back, drop it back down the hole, and off you go. So, and this right here, not the best illustration I found, but this kind of gives you an idea of how that works for pumping out the water. Little cups come down, grab the water, up they go. They hit the delivery point, out it goes, around it goes, rinse, repeat. In this case, the cups are actually tipped over by a special mechanism, and over they go. In my example, they come in this way, and they get to the top, they tip over, then they return down to the well again. So, anyways, that's basically how this works right here, and that's both ways you can do this. Either one works. If you like the cups, you can do the cups. You can do the chain pump with the plugs. Now, the advantage to this, which you can also do the same thing with the chain plugs, the advantage to the little bucket pump on the chain here is you can space those out quite a bit. So like if you know that towards the bottom you're dealing with 80 psi or 80 pounds of possible water weight, and your system can only do, say, just to throw a number out there, 40 psi. Okay, well what you do is you space out your cups so that, yeah, it slows down pumping, but you have less weight on the line, and you're only having to push up to 40 or lift only like 40 pounds of water at one go. So that one has more versatility. The other one I think though does a well. The other one's faster. The first one I mentioned, this one is faster. You can also space out the plugs on this one, but at the same time, that doesn't solve the problem of the water weight. It just increases the size of the. Let me go back here. It just increases the size of the cavity, so that doesn't solve the water weight problem. That just increases the spaces, which can create more problems, because you're better off having the smaller cavities than you are the larger ones. So, this one I would say is the faster one, but you're also going to need more horsepower towards the end to make this continue working. This one might take longer, but once you get towards the bottom and you start really getting into that water weight, it can just keep running, keep doing its thing, and shouldn't have any problem. You can dial it in to be within whatever the resource limit is for your windmill. If your windmill can only lift 40 pounds of water, fine. You set your cups to do 40 pounds of water, maybe 35, 30 pounds, whatever you want to dial it back to give it that little extra bit of oomph, and it's not having a struggle to get to the top. And anyways, that's the pumps. That's the latest puzzle. I still have a few more to show you, but I gotta kind of work those through and try to figure out how to explain those, because those are a little bit more difficult. Not difficult so much in the puzzle, but more difficult to explain. But I'll explain this to you as well, and I'm also going to go and circle back to the pump that was the Desert Spring one, and try to show you what I have so far on the design for the secondary electric backup system. Again, not a mechanical puzzle, but it was a nice little addition that I added that I thought was, if you were actually building this system in the desert and you needed access to that water, that was the best way to do it. Because if your slow flow rate is only a quart an hour, that water is going to be as precious as you can possibly think of. So how do we make this system work for us and take advantage of all this different all these different things, and because you got 4,000 gallons of water accumulating at the bottom of the hill under that ram pump. You got to be able to use that at some point. So yeah, like I say, it's outside the puzzle, but at the same time, how are you going to apply this practically? So anyways, thank you everyone for listening. I will check in with you again sometime soon, and if you have any questions, comments, please feel free to leave them in the comments section below. Thanks.